Hi everyone. I hope you all can see my screen. Okay. So let me just share my screen and we will be starting off with the post analysis of today's contest. Let me just share the screen and you guys are up with it. Cool. Let me just check if you guys are able to see it. I think that's fine now. Okay, so today you were given these questions. Let me just move to the all the problems. So these were the questions in your contest. So let's start one by one with each of them and starting off with maximum average among all sub arrays. So the question was very easy. So what you're given is you're given an array A of n elements. Find the maximum average value among all sub arrays of the array. Okay, so just give me a moment. I'll quickly write this. Any this case we can write. Just a second. Okay, so let's say you are given. One moment. Just okay, fine. This was your question. Cool. Starting off with the first test case that you are given. So you are given an array with n elements. Let's say here you have 2, 4, 6, 8, 9, 10, and 12. Okay. What you had to return was you should return in this question what is the maximum average sub array. So what you can do in this problem, if I talk about brute force, you can definitely start off with finding all the sub arrays, find out the average of each sub array, the one with the maximum average. You have to return the average itself and not the sub array, right? But that's a brute force approach. We can definitely do better in this problem, but before, for those who are very, who just starting off with this question, let me tell you, when I talk about sub arrays can be any, can be the set of arrays with consecutive elements in the array itself, correct? So it can be an entire array also, and it can be subparts of the array. So let's say I take one example of 2, 4, 6. This is one of your sub array. So what is the average of this sub array? That will be 2 plus 4 plus 6 divided by 3, right? That will be 4. 10 plus 2, 12 divided by 3, 4. Okay, so if I go ahead and check each sub array and find out its average, then the one with the maximum average I have to return. Okay, so one thing, this question can be very easy if you come up with one observation, which is, it's, you can say it's a little bit of mathematical manipulation, which is simply, if you observe, whenever I take average of any number, let's say A plus B plus C plus D, okay, so average of four numbers will be sum of these four numbers divided by 4. Okay, so if I write it like this, it is typically A by 4 plus B by 4 plus C by 4 plus D by 4. Okay. Tell me one thing. What can be the maximum average that I can find from the array? For example, if I take all the, let's say these are the total elements in your array, and I've taken the entire array itself and I divided the all the elements of array by the number of elements only. So I am going to get something that is 1/4 of total sum, right? Total sum. But if you closely observe one thing, if I just take one element, so one element's average will be what? One element, let's say this is your given array. If I take a sub array of just one element, so the average of one element will be that element divided by one, which is one only. Average of one element, let's say I take a sub array with only two in it. Okay, so that will be two divided by one, that will be two again. So one thing I can easily say that what if, and if I do take all the elements in my array, what is your sum going to be? 3 plus 2, 5 plus 1, 6 divided by 3. So the answer will be 2, right? And if I take just two elements, that will be 3 divided by 2, that will be 1.5, or in terms of integers, it will become 1. So, do you see one thing? I can always say that element, the sub array with only one element, is going to be a bigger sum that in terms of others, because I am dividing it by one only. That means I am getting my answer as that element itself. So if you see, if I just find out which is the maximum element in my array, don't you think that is the answer itself? Because 3 divided by 1 will be 3. Are you ever going to get the answer as 3 for any of the sub arrays which you take, which is not including 3 as the only element in the sub array? Let's try it out in this given test case. So, see the solution, if you see, it's nothing, it's very simple, as you have already observed here. What did we do? We just found the question comes down to finding the maximum element. But the question is why? So to answer that why, look here, why are we finding just the maximum element, and we are saying that the maximum element itself is going to be the answer for this question? The reason is whichever sub array you choose. For example, if I choose a sub array which is 10 and 12 only, okay, so 10 plus 12 divided by 2 is going to be my average, which is 11, right? 10 plus 12 will be 22, okay? If I just choose, and if I do it like this, 12 divided, it can be written as 12 divided by 2 plus 10 divided by 2. So one thing is for sure, whatever average I'm going to get, whatever answer I'm going to get, do you think it will ever exceed the maximum of these two? What is the maximum of these two values? Let's say I'm considering a sub-array which has only 10 and 12, right? The highest element and the second highest element, just for example. So the average in this case, do you think average will ever exceed the maximum value of your elements? No, because it has already got converted into some fraction. We are adding up some fractions. So that is never going to exceed the maximum value. So by making use of this observation, this mathematical observation, or you can say we have, it's nothing, it's simply just using some understanding and playing around with averages and seen this thing that anyway, whenever you are finding average of elements, more than one element, you are always dividing it. You are always going to get a denominator which will be heavier in weight as compared to one, obviously. So I will never get the answer which is greater than the maximum value. So no matter, even if you take the entire array, your your denominator's weight will increase. So you are never going to get an answer which is greater than 12. And if I choose to go ahead with only one element, you at least you will get an answer which is equal to that element itself. So why not choose the maximum of those elements? So in every case, your question comes down to finding the maximum element from the array. So what have we done? You can do it by taking any types of variables you want. So m for me represents max here. So you took m as a variable and initialized it with the first element of your array. Then I'm iterating over all the elements of my array and keeping a track of element which is greater than the value stored in m. So I go at 2, I see if 2 is greater than m. M right now is 2. So obviously, m will not be updated. I go to this element, it is 4. 4 is greater than m. M will be updated with the maximum of these two, which is 4 in this case. So you go to the next element, find it 6. So 6 is greater than 4. So m will be storing in this case 6. You go to next element, you find it is greater than m. M will be updated with 8, and so on and so forth. Finally, when you come out of this loop, your m will be containing the maximum element in your array, which is 12. So, coming on to the case, let's say all the elements are same. Let's say you have 3, 3, 3. Okay. So this is your given array. In this case also, in this case also, now you will see that I have elements which are all of them are same, right? So even if I do average of all the elements, that is I take my sub array as the entire array. then also the answer that I'm going to get is what? 3 only, which is the maximum of your given array. So this observation works for all the cases. So if you have any doubts, you can write in the chat. Let me just check. Okay. The question stated that the n will be, yes, n is the array length. So voice is not clear. Let me just check if my voice is clear to you. Let me know if it's better. Is it better now? Okay, so Ruhika and Vivansh. Okay, thanks. If you have any doubt in this question, can you please elaborate? What is the doubt with n in the question? So n is the number of elements in the array. That is the array's length. That's all. Nothing else is required. Okay. So shall we move to the next problem? Okay, great. Moving on to the next problem. So this was a very simple problem, but obviously to think of this thing that maximum element itself serve as the answer for this problem is a bit tricky part. So even if I'm also trying, I'll think of the brute force approach that, okay, checking all the summaries, taking their averages, that is the very brute force approach, but you have to think something efficient. So obviously this is an easy problem, but to think and get to this trick part is not that easy. So it's a good question. Okay. So let me move to the next problem. Coming on to the problem, which is the final task. So this problem is based on bit manipulation. Again, if you have done basics of bit manipulation, then this question is easy, very easy. So even if you have not done, nothing to worry, we will discuss it now. Okay. So the question says, this is written. Okay. Ultimately, the problem is you need to count the total number of set bits, or you can say the total number of ones in the binary representation of each number present in the array. Okay. So these are the numbers that are given to you. For each number, you have to think of first of all what is their binary representation. Then in the binary representation of each of these numbers, what is the count of one in them? Then you have to add the total number of ones present in their binary representation and return as the answer. Okay. So let me just move to the whiteboard and explain this for you. So let's see. So the question is the final task. Fine. So second problem, the final task. Okay. Let's cut this question into short. Means let's divide it into a very smaller sub problem. You are given an array, okay, which has some integers. So let's say I have one, two, three, four, and five. So I have to tell that how many ones do each of these elements have in their binary representation. And you have to add them all and return. For example, binary representation of has only one set bit. Two has, let's say, only two set bits. One has only one. Four has only two. Let's see. So you have to do sum of all the set bits and return. How can we do this? Now, again, starting off with the brute force, you'll say, okay, we will take each element one by one, convert them into their binary representation, okay, and then we will return that answer. Okay. So, first thing, why we will not go ahead with this approach is, why do I store them separately? First of all, I convert them into their binary form. I'm storing them. Let's say temp in some int of type of temp. I'm storing these values, and then I am iterating over each bit and checking how many ones they have. So this is a costly approach. I can do it. efficiently by using bit manipulation. And how? So what can we do is think of just one element and tell me how can I find number of set bits. Let's say there is this function which takes some integer n, and you have to tell me what are the number of ones. When I say set, so you should be knowing this term also. When I say set bits, it corresponds to how many ones you have in the binary representation of any number. Binary representation of any number. So if I take an example, let's say I am 15. Okay. So binary representation of 15 is what? Not that you have to go ahead and do this binary representation. This is just for your understanding. If you don't know how binary represents binary numbers form of these, so this integer, each integer of decimal type, decimal form. I am converting it into its binary form. So what is the remainder? 1. Okay. What is the remainder? 1. What is the remainder? 1. Remainder 1. So 0, 1, 1, 1, 1. This is the binary representation of 50. Okay. So like this, I can take any number and find its binary representation. Now, if I want to find what is the how many ones does any number have? Let's take number 5. So 5 can be represented as 1, 0, and rest of them can be taken as 0. Right? Okay. So let's start. If I do this binaries and with 1. Okay. What is this? This is bitwise operator and bitwise and correct. So if you are aware of bitwise and you would be knowing that only when I have last bit right as 1, I will get the final resultant as 1. And if I have the last bit as 0, I will have my result as 0. Okay. So when I'm doing it bitwise and with 1, so the preceding bits can be taken as 0. Bitwise and of it will be what? Since it is 1, I have 1 in my answer, rest of the things will be 0. So if I got my resultant as 1, your resultant is 1. It means the bit that you were checking for was 1. So let's say I took a variable count which is incrementing whenever I'm finding a 1 in my number. Okay. So this represents 5. Okay. This is the binary representation of 5. So I have to return 2 for this number. Okay. So I'm checking that. Int count has been incremented by 1 because I found 1 by doing bitwise AND of this number with 1. Okay. Now do one thing. Do a shift by 1. Shift of what? I want to do a right shift of this n by 1 because I have already seen this bit. The least significant bit is 1. So just shift your number by 1 index. So your bit will come out to be, your n will be, in this case, it will become what? When you do a right shift or a left shift, you are, if I'm doing a right shift from right, that is the least significant bit is removed, and you shift all the bits by 1 index to the right. So this becomes 0. This 0 comes here. 1 comes here. And rest of them are 0. So it will remain 0, 0. You don't even have to write it. Okay, let it be just 1, 0. Now repeat the process. Do a bitwise and with 1. So when you do a bitwise and with 1, since least significant bit is what? It is 0. So you are going to get your resultant as 0 only. This is your result. So if you find your result as 0, will you increment the count of this count by 1? Not at all. Because this represents the bit that you were checking for your number n had a 0. That is why I got my resultant 0. Okay. So since I have checked for this bit also, do a right shift again. Now when I do a right shift again, your n is going to look like what? This bit will be removed and this will be shifted by 1. So now you have 1 only and rest of them is 0, 0, 0. Do a bitwise and with 1 again. So final answer is 1. As in when you get a 1, you increment your count. Now your count is 2. So now you do a right shift, and when you do a right shift again, your number becomes 0, 0. So as soon as your n becomes 0, you know that you have counted all the ones that you had so far, right? So that means by doing right shifts, now you have reached when your n becomes zero. You don't have to check for further, and you will simply return count. And this thing you will do for each element in your array, right? So what we are doing, we are typically if your n and bitwise operation of n with 1, if this value is equal to 1, right? So I will increment the count by 1, correct? Otherwise, we're doing a right shift on 1. N will become right shift. Okay. Right shift means what? You are actually multiplying. Then in terms of decimal, you are multiplying the number by 2. So let's say what is the representation of 2? 2 can be represented as 2 is represented as 0, 1, 0, right? In binary. This is binary and this is decimal. So 2 multiplied by 4 is 2 multiplied by 2 is 2. 4. What is the binary representation of 4? Binary representation of 4 is 100. 100. So what I did in terms of bit manipulation. So when I'm doing a right shift, I am actually removing the last bit. Okay, sorry, that is opposite. When I'm doing a left shift, I am actually multiplying that element and moving last bit and shifting the element by one position to the left. So that's how it turns out to be this. Sorry, I just told the opposite. Means in left shift, it is dividing by 2 to the power of k. K represents the number of times you are we shifted only once. So it is this. That's what. Okay. And since we were doing a right shift, it becomes 1. That is 0, 0, 1 opposite. So you're dividing the number by 2. That's how you are removing the last bit and shifting each bit by one index. So I just went into the depth of what left shift and right shift is in case you do not know. Because this is a prerequisite for this question that you should be aware of some of the concepts of bit manipulation. So what we discussed here was we did a bitwise and this thing will go on until your n becomes zero. So while your n is greater than zero, you are doing this thing and finally you will return count. Okay, so that's what we have done also. Let me check audio issue. Let me see. Wait. Just why is this audio issue coming? Um, guys, tell me, guys, or let me just see here only. I'm just taking this off. Can you tell me if my voice is clear now? Let me know if my voice is still not clear. I think that was the issue that I. Okay. If you understood this problem, let me know. We will move ahead to the next problem. So, so what I explained you was this. So the code that I have written is in Java. So I hope you can understand. The logic is important to understand. You can code in any language that you are well versed with. Okay, fine. So the thing that I discussed was I am doing a bitwise AND of n with 1. If I get a 1, that tells me that the last bit is 1. So if I found 1, I am incrementing the count and also shifting my number by one position to the right so that I can check one by one, which all bits are 1. So that's the very conventional way that we do in bits. So, okay, it's clear. Good, fine. So moving ahead to the next problem. Any doubts, guys? Any doubts? I'll just give you a minute. Then we will move to the next problem. Well, thanks for the appreciation. Okay, so let's go to the next question. You can take your time. If there are any doubts, you can go through the code here and you can ask me. So this is also, see, if you understand the concepts of bit manipulation, then this is also an easy problem. Okay, not at all hard, not at all. Moving on to the next problem. Okay, so you're given, the problem statement says that you're given an array a of length n, and there are two operations that you can perform. One to any array element, subtract one from any array element. You have to perform exactly one of the above operations on each array element. Now from the updated array, you need to return the count of element that has the maximum frequency, and so on and so on. So let me just directly move to the board and explain you this problem. I'll just write the test case. So the third question now we have is this. So this is add and subtract. Add and subtract. Okay. So let's see this array which you have here is A is given as 1, 3, 2, 4, 3, 2 and 1. Right now, you have these elements in your array. And you can perform total 2 operations. So those 2 operations are, on any element of your array, for any element of your array, you can either increase that element by 1 or you can decrease that element by 1. So you will get some updated array. So from that updated array, you have to tell what is the maximum frequency that any element is getting, or what is the number of times that we are getting an element, which is the maximum number of times. Okay, so let me just show you so you will understand, not in the terms of language, but yeah. So just let's assume we have an array which has elements like this: 1, 5, 10. Okay, I can perform 2 operations on each of the elements. So let's take a smaller one, even smaller, 1 and 2. The operations that I can perform is, let's say this is your 0th index element, this is your 1 index element. If I am incrementing the 0th index element by 1, so the array will look like what? What combinations I can make? I can, let me just give me a second. Okay, so either I can increase, I can decrease. So what combinations I can get? So increment 0th index, this first arrow is for 0th index element, second arrow is for first index element. I have taken the smaller array to help you understand this question. And the other element also, either I can increase it by 1 or I can decrease it by 1, and I have to perform any of these things I have to perform. So if I increase this one also, so what is the array that I'm going to get? So if I do this, I'm going to get 2 and 3, right? This is my updated array. Let's perform other operations. What can be the other combination? So red represents the next thing that I can, the possible option now. So do one thing, increment the first index and decrement the second index. So array that you are going to get is 2 and 1, correct? What is the next possibility? Can we do something else? Let's see. So decrement the first index and decrement the other index also. And let's write the other possibility also. You decrement the first index and increment the second index. Have we seen all the possibilities? So see, these are the possibilities. I have 2 elements. Okay, let's say A and B. First I increase A by 1 and B by 1, plus plus, right? Plus plus. Other is I do minus minus. One is plus and minus, other one is minus plus. So these are the four options. So these four options I am exploring and checking what is the final updated array that I will get. So in this I am doing minus minus, so I will get 0 and 1. In this I am doing minus on first, I will get 0, and plus on second, so I will get 3. So now you see I have the total 4 options which I have written in front of you. And out of these 4 options, which array gives you the maximum frequency, that is the repetition is more. If you see, it has 2 ones, 3 also ones. It has 2 different elements, both are coming only one time. It also has 2 different elements, all one time. So maximum from this is going to be 1. The frequency will be 1. Any element that I'm getting from any option is only 1. Let's just change the test case, and let's say your test case was this. 1. I have 1 and 1. Okay. So let's see what is the answer in this case. Incrementing both. So I'll get 2, 2. Okay. Plus and minus. 2 and 0. Right? Minus, minus. 0, 0. Minus and plus. Minus and plus will be 0 and 2. Right? So from here, again, frequency will be 1. Maximum frequency is 1. Maximum frequency here is 2 because I am getting 0 2 times. Maximum frequency here is 1. Maximum frequency here is 2 because I'm getting 2 twice. So for this test case, the answer that I will return is 2. Now wait, what are we going to do? If I go ahead and check one by one all the options for each element, so this task will take me 2 into n time complexity. So it will be kind of, because I have 2 options for each element, and let's say number of elements are n. So am I going to do this thing for 2n times? No, I'm not going to do this. I can definitely do a better thing for this question. What is it? Since you see I am having some elements, right? Let's create a map of these elements. Okay, so if I create a map of these elements, let's say I had one. What I want to show you is, if I create a map for this itself, I had 1 1, and for all the options, right, I am updating my map. Okay, let's say initially my map was this, 1 was coming how many times? 2 times. So right now my map status is 1 coming twice. Okay, this is my map status. Now I explored all these options. Update your map. So your map will look like what? So initially it was like this. Now what do you have in your map? You have 2 twice. So 2 will come 2 times. From here you have 2 one more time and 0 one more time. So this will be 3, and 0 has come up once. So I'll write it as like this. Okay. So, and also initially I had 1. So I will just remove this step. Wait. Start updating your map as if you have explored all the options for this case. Okay, so what all options you have, store it in map. If I store it in map, what my map will look like? You got 2 how many times? 2 times. Okay, so you got 2 from here one more time, so your 2 will be 3, and you have got 0 1, so 0 will be added 1. Now you got 0 2 more times, so it will become 3, total of 3. Okay, now you got a 0 one more time, so it will become 4. And you got a 2, you got a 2 once, so it will become, what did I do? It should be updated. Okay, this becomes 4. Just give me a moment. Let me just evaluate this thing so that I can tell you for the original test case. And now I have 2. I am having 2 twice. So this is what I am going to do. Fine. So coming on to the problem. So I was just verifying one thing. Now coming on to the original test case. So why did I show you this? This is because I want to come up at this thing that this is your given array, right? And see, what we are doing in this question is that I am creating a hash map, right? But what am I doing? You know that for each element I have 2 options, right? So I am updating my map accordingly, that if I am, let's say, if I am decreasing that element by 1, so what will be the status of my map right now? It map.getOrDefault is that function which gives you default if ai minus 1 will be present, so whatever is its value it will add 1 to it. If it is not present it will add 0. If it is not present it will add just 1. Okay, so just 1. If it is already present then whatever is its value it will be added by, it will be added increased by 1. So that's, I hope you know what is this map.getOrDefault. Now, what are we actually doing in this question is, see, again, the code is very simple. But the thing lies in concept that why are we doing it? So the problem lies down why. Okay. So let's get an answer to this why. So seeing our problem statement, the solution that we have written for it. So if I try to do a dry run according to that solution, what am I going to get? So right now, let's say you have created a map. This is your map. Okay, you created a map which is empty as of now. You iterate over this array one by one. Right now, your I is at 0. Okay, so your map says map dot put ai minus 1. So ai minus 1 is what? 0, right? So it will add, does your map contain a 0? No, 0 will be added with 1 in its index. Next statement says map dot put ai plus 1 and map dot get or default this ai plus 1 0 plus 1. So what it is doing in your map, put out what ai was 1, 1 plus 1 will be 2. Okay, so you add a map, in your map you add an element 2, and what is its default value? We do not have any default value, so we will add 1 to it. Okay, fine. Now your I comes at this index. Again, check for two values, one by decreasing it, one by increasing it. So if you decrease it, you get a 2. And what is the default value of 2? It is 1. So increment it by 1, that is, it will become 2. And if you increase this value, you will get a 4, which is not present in map. So 4 will be added with value 1. Do the same thing for 2. Okay, now for 2 what do I have? I will have 1 and 3. So 1 is present? No. So you will add a 1 with 1 and 3 with 1. Okay, fine. You go to 4 now. Is 4 already present? Yes. So it will be, so for 4, for this you had 1 and 3. Okay, for 4 you will have what? 3 and 5. Correct? So 3 is already present, add it with 1. And for 5 you have nothing. So you add it and it will become 1. Now for 3, you have 3 again. You will have to check for 2 and 4. So 2 will be added by 1 and 4 will be added by 2. Correct? So now you are at 2 again. So for 2, what do we have? We have 1 and 3. 1 is already present, increment by 1, and 3 is already present, incremented by 1. Correct? Okay. Now you are back at 1. You will have to check for 0 and 2. So 0 is present, incremented by 1, it will become 2, and 2 is already present, incremented by 1, it will become 4. Okay, fine. So now see what is the maximum of the values in your map. You see that we have the maximum frequency as 4, that is corresponding to 2. So how is this map giving us the answer? If you check, we have to return 4 only. Because if I do some operations, which I will just show you, I am going to get an array like this, which will have maximum number of rows. So that is what I am returning actually. Now the thing is, how am I getting this answer? Let me check if you guys have anything. Okay. Right shift and map.getOrDefault, I will tell you. Wait. Okay, talking about recursion in this problem, there is no use of recursion, means that I wouldn't suggest at all to solve this problem using recursion. See, first of all, identify why should we use recursion here? Do we see any repeating subproblem? Yes, there is subproblem. You are definitely correct. We have two options for every element. That is by adding it, and one is by subtracting it. Okay, then I am checking if my map contains. But tell me one thing, when I can simply use iteration, why do I do it using recursion? Is it saving me any time? No, it will not save me any time. Rather, it will increase the space complexity, that is the internal stack for that it will take to store the call stack, make the call stack store into it. Okay, so there is nothing better which I can get from recursion. So okay, coming back to it, why are we doing this? Okay, so see here, this was my array, this was my original array, 1 3 2 4 3 2 and 1. What I tried to do is, for every element, I checked if I add it, if I explore plus option or its minus option, and I am doing the same thing for every element. See, if I have elements which I'm getting by adding, okay, and let's say subtracting some element is adding to that element, so that answer will be stored in the map for that particular element. And let's say if adding that element is affecting some other element by subtracting it, that will also be reflected into your hash map. So basically I have stored all the options in my hash map. Now on doing all of these things, the one with the maximum frequency will be my answer. And how am I getting it, that I will show you. So in this array, if I do a plus operation on 1, it will become 2. I do a minus operation on 3, it will become 2. If I do a plus operation on 2, it will become 3. If I do a minus operation on 4, it will become 3. If I do a minus operation on 3, it will become 2. I do a plus operation on 2, it will become 3. I do a plus operation on 1, it will become 2. So let's see how many 2's we have. See, we have maximum number of 2's, which is equal to 4. How many times I'm getting 2? That is 4. Now, what I did, I checked all the plus and minus options for all the elements. I stored it in map. So the element which, after doing all the additions and subtractions from any element, if it is affected, it will be reflected into your map. And still, if I'm getting it as the maximum, with the element with the maximum frequency, I will simply return it. Okay. So that was all about this problem. You can ask me if you have any doubts. So this thing we are doing in exactly O(n) of time complexity. In one pass we can do. Yes, I'm taking some extra space of hash map also. So this is typically of O(n). Maximum it can go till O(n). But this is a very simple, a little tricky to think that why not do all the operations at once and store it in my hash map. It will tell me, it will directly, I will iterate over the values or in the map. The one with the maximum value will be the element, and if I want to return frequency, I will return the frequency. So that is all. Okay, fine. Talking about right shift, after all the discussion, now one more question is left. I'll come back on right shift. So those who will have any doubt in bits or right shift, I will explain that again. Okay. So I hope you all understood this problem. Let me know if you want to discuss anything else. I'll wait for you guys. I'm sure a lot of people must have done with different approaches, but this is what we can do in the simple way and the efficient way. You can try out others as well. So see, collections, obviously in Java, Jitasha, we use collections, and in C++ you can use STL. You don't, it depends. Mostly when you have hash map, in interviews you will not be asked to implement a hash map. No, there is a queue. You'll not be asked to implement a queue. Yes, you might be asked questions like how do you create a heap. For example, if I talk about, we know what priority queue does, but you should know how priority queue can be created, how heap is being created. So these things you need to know, but very rarely you are asked to implement everything from scratch. If in Java we have this utility of hash map, we can directly use the hash map. We can use all the methods of hash map. Same goes for stack, linked list, array list. You are not required to implement it from scratch. Okay. So that is not what interview wants to know, but concepts of DSA you need to know. So these things wouldn't matter much. If you know that if you're using Java, let's say, you know hash map is there. What does hash map do? You should know the basics behind it. How You don't have to implement hash map because Java contains the methods of hash map. You are allowed to use that and you should use that. So that is about it. Okay. Fine. Moving on to the next problem. Airline problem. So I'm giving you a minute, and in a minute we'll start off with this question. Meanwhile, if you have any doubts in the previous ones, you can go through your code, my code, and check it. In a minute, I'll start with airline problem. Just give me a check if you guys have any doubts. Okay, then I think we can move to the next problem now. Okay, starting off with the next one. So airline problem. So this question has given you some routes, okay? And this is a 2D array which contains each array, each array in this routes 2D array has three values. First is the source. You can take it as source. Other one is to the other terminal at which it can reach from this source, and what is the cost of reaching from this source to this destination. So from 1 you can reach to 2 in 9 cost. From 1 you can reach to, let's say these are some terminals of airport, right? So that's what you are doing. So from 1 you can reach to 3 in 10 units of time, and so on and so forth. So I'm just going ahead and creating a tree for you to understand that what is happening in this question. So let's have a look. This is your fourth question. Just saying airline problem. Fine. Okay. So this problem says that you are given routes which contains arrays. Each array has three columns. One column can be treated as source, other can be treated as destination, and this tells you cost. So on the basis of given routes, I am just creating a tree so that you understand what from which terminal you can go to which terminal. Other thing that they have told you that you have total three terminals, okay, 1 to n, and for first test case your n is 5, right, and m is 7, which is the number of, that is the length of your routes. Okay, so let's see how they have given you. I am going to create a tree for this routes. Fine. Okay, so I have one. From 1, this is your source. From 1 you can go to 2. Okay, in how much of time that I am writing is 9. Okay, from 1 you can also go to 3. In how much of time? 10 units of time. Let me write the weight on their edges. This is 9 units of time. This is 10 units of time. Then from 1, can you go to any other place? Yes, from 1 you can go to 4 also. From 1 I go to 4. In how many units of time? 2 units of time. Okay. You just, what I'm drawing here, you can just map it with the roots that has been given to us. From 1, where else you can go? From 1 you can go to 5 in exactly 6 units of time. So let me write 6 here. Then from 2 you can go to 4. From 2 I can go to 4. Okay. From 2 I can go to 4. So let me just make it like this. It is actually a graph structure, okay, not a tree. So from 2 you can go to reach 4 in how many units of time? In total, 2 to 4 is 14 units of time. Okay, fine. What else? 2 to 4 is done. 2 to 5. So you have 2 to 5 also. Let me redraw. So 2 is also connecting with 5 in how many units of time? 2 to 5 is 2 units of time. 2 to 4 was 14 to 5 is 2 units of time, and 4 to 5 is 11. Now you have 4 to 5 in 11 units of time. Okay. So if you see, this is an undirected weighted graph. Do you observe this? Okay. So let me draw this graph nicely. I'll take a new page. It's not copying. Just a second. Actually, I want to just redraw it so that you can visualize it in a better way. Let me do one thing. 1, 2. This is your 1. Okay. Then I have 2, 4, 5 is 3. Okay. Let me see what we had. 1, 1 to 2, 1 to 4, 4 to 5. 1, 2, 4 is a triangle. 1, 2, 4 is a triangle. Fine. So you see this 1, 2, 4 is a triangle. Then 4, 5, 2 is a triangle. 4, 5, 2 is a triangle. 4, 5, 2 is a triangle. Then we have 1, 4, 5 is a triangle. 1, 4, 5. 1, 4, 5 is also a triangle. Okay. So writing their weights. 1 to 3 is 10 units of time. 1 to 4 is 2 units of time. 1 to 5 is 6 units of time. 4 to 2 to 4 is 14 units of time. Okay, 2 to 5 is how much? 2 units of time. 4 to 5 is 11 units of time. And have I written all the weights? 1 to 5 is 6. 2 to 4 is 14. Yes, I think it's okay. 2 to 1. 1 to 2 is 9 units of time. Okay, now you have to find the maximum cost that will take you to start from 1 and reach to nth terminal, which is 1 to 5. So which path will give you the maximum cost? If I start from 1, I can go to 4 and I can go to 2. Then see, you have to explore the options 1, 4. From 4 you can go to 2, from 2 you can go to 5. This is one path. What is the cost of this path? If you start from 1 to 4, you get 2. So 2 plus 4, 14, right? 16, 16 plus 2, 18. So this is 18 units of time. So you start from 1, go to 2, go to 4, 1 to 4, and then you go to 5. What is the time that, what is the cost that you are taking? 1 to 2 is 9, 9 plus 14, 23, 23 plus 11, 34, right? So you have 34 units of time if you take this path. Let's check. Direct 1 to 5 is how much of time? 1 to 5 is 6 units of time, if I'm not wrong. Yes, it's 6 units of time. Okay. So I explored few paths in which I can go from 1 to 5. And I checked what is their costs, right? These are costs. So which path is giving me the, are there any other paths possible? 1, 4, 5 is possible, but it will take only 13 units of time. So obviously not a good option. So do you observe one thing, that as longer the path I am trying to get, basically I want to get the maximum cost. So in whatever way I can get the maximum cost, I have to explore that option and return to my final answer. So first thing is, are you even able to reach to that destination which by the path that you are choosing? Let's say I can go from 1 to 3 also, but from 3 can you go to 5? No, you cannot go to 5. Okay, this is one thing. And what if you start from 1, 4, 2 and go come back to 1 and then go back to 5? Is this allowed? No, that is also not allowed. You cannot come back to the source from where you started and then you reach to the destination. So by these two options, if you have studied graphs earlier, then one thing should surely come to your mind. I can this looks something like Bellman-Ford algorithm. What? But the only thing is, in Bellman-Ford algorithm, we used to find minimum cost path, right? Minimum weight path. But here you have to find the maximum cost path. That is the only difference. So that I can handle. But typically, what I want to show, what I want you to understand is that typically that is the kind of approach or logic that we will apply for this question. So what I'm going to do is, I will start from 1. I will use DP here, okay? Means I will be making use of previous answers. I will check if, first of all, if I start from 1 and I go to 2, right? So for 2, what is the cost I am getting? It is 9 right now. Okay, I'll take that 9. From 2, I go to 4. First things that I have to check, whichever path I'm choosing, that the location, the terminal at which I'm going, is, has it already been visited? Okay, first thing. Second thing is, there should be no coming back, means I should not be coming back to my source. So these things, if you have done this, this is definitely very simple, just implementation of Bellman-Ford algorithm with some changes. The changes are, we want to maximize this cost. So what we will do, initially you are given, what you are given, you are given the roots array, right, which has some cost which is positive. Let's make these costs negative by multiplying each of the cost by -1. So if you have 1 2 9, 1 3 10, okay, 1 4 2, it will become negative. Now from negative, what is the minimum value we will get? Let's say these are 3 costs, this is the minimum. So finally, if I know this is the minimum, I can return -10 multiplied by -1. So I will get the maximum cost. Just saying that we can do this kind of manipulation. Let me see if you guys are up with me. Okay, guys, they are with me till here. This is a good graph question. So again, it's a simple graph question only if you know graphs, if you have studied some algorithms of graph. Okay, so coming back here. So this is the thing that I will handle if I want to implement my Bellman-Ford algorithm. Okay, now next thing. So I hope this much is clear to you all. what is the idea? That we start from a single source, we start from a source, and we calculate the distance, which is in terms of cost here, to each node. Okay, and I want the maximum one. So in this case, I am converting each cost by -1. So from negatives, the minimum cost that I will get. Okay, so in negatives, what is the minimum? This will be the minimum of these three values. I can simply multiply it by -1 again and return it. So this thing can be handled like this. Okay, so let me just move to the code and tell you. So in our implementation, what are we typically going to do? We are going to detect if we have a negative cycle, right? If that is the case, that means I'm not able to reach my destination only, or I am detecting a cycle, I'm coming back to the source. So in these two cases, I will return -1. In other cases, I'm going to update my answer with the minimum of these negative values. And finally, I can get the maximum from them, correct? So let's see what I have done here. So this is what we are doing. The first thing that I told you, you are starting off in your roots. Your roots has 3 columns. Third column represents what? Cost. So first of all, I'm updating my root with cost to be negative. So wherever I have 9, 10, 2, 6, 14, it will become negative. Okay. So this I have taken some, and you have to return your answer of type long. So I'm taking each of these variables as long. So this is the maximum value that I'm taking in your language infinity. That's, let's say I've taken infinite value like this. And this is the array that I've taken to store the answers. This distance array I'm taking. So this dis array which I have taken of length n+1, what it is doing. So how many terminals I have? I have total 5 terminals. So I'm taking of length 6, so that 0, 1, 2, 3, 4, 5, and 6. So this is my distance array, right? Okay. I'll show you what we are doing every time in this distance array. Now what I'm doing is, next thing, you can see the code. Next thing is that I am filling this distance array with the maximum value initially, so that I can always update the minimum for that source, for that particular terminal at which. So you can treat 0, 1, 2, 3, 4, 5, 6 as the terminals. Okay, so each of them initially I am updating with maximum value, which is infinite value that I have taken as using variable inf, infinite. Okay, moving on. Next thing what I'm doing is, see, so you need to understand this dryer, and that is the most important thing. Now I am just storing this of 1 with 0. Okay, so right now this value is 0. Fine. Why we are doing so? Because we are starting from terminal 1. So the cost to reach a terminal 1 is what? 0 only, right? Because we are starting from 1. We have to find the maximum cost starting from 1 to terminal n. Okay. Now this is the parent array that I am taking, again of same length as distance array. This is your dis array, and this parent array is also of the same length, 0, 1, 2, 3, 4, 5, 6. Correct? Fine. Next thing, I am iterating over these roots array. Okay, so for as many terminals I have, for each terminal, I am going ahead and checking what is the cost. Okay, so for each terminal starting from 0 to n-1th index. Okay, now what you're doing for int j equal to 0, m is what? M is the length of your roots array, right? Now you are checking this of this is what? This array roots j of 0. If j of 0 represents what? 0th column represents your source. If this is infinity, that means we have not explored that path. So do not just continue and check for the other index. Okay, so this represents this. You will get understand it more better when we proceed ahead with more indexes. Okay, now currently my I and j both are 0. Let me write it here. So I'm doing I is 0, your j is 0. Okay, and you have that roots array. Fine. Initially what I'm checking, what is your roots j of 0? So roots 0, 0. 0 0 is this value 1, correct? If this is this infinite? No, it's not. Your dis of 0 0 is what? 1. So distance of 1 is what? It is 0. It's not infinite. So I'll not continue. And I'll go to the next statement. I'll check distance of roots j comma 1. That represents j is what? 0. Roots of 0 comma 1 is this. That is from 1, which terminal I can go to. From 1 I can go to 2. Okay, so if distance will store, distance of each index will store that what is the minimum cost of reaching 2, okay, from parent, which will be represented by parent index. Okay, so if I am reaching to 2 from 1 in some time, let's say, which is less than the value present here, let's say 10 units of time, so I will update 2 with 1 in my parent array. Okay. So that I can know that I reached at destination or at my terminal 2 using which terminal. So that will be updated and in how much of cost this will be updated in your distance array. So this is asking if this of roots j1, it is greater than this roots j of 0. So j of 0 is 0 comma 0, root 0 0 is 1. So what is dis of 0 0? That is distance of 1. Distance of 1 is 0 right now. 0 plus roots of j comma 2 tells you the cost of reaching from 1 to 2. That is 9. So 9 plus 0 is 9. 9 is less than the actual value that is present at distance of 2. Is that fine? Since this value is less, I will update my distance of roots j comma 1. J1 is what? J is 0, 1 is this. So distance of 2 will be updated with maximum of minus infinity and the value that I found here, right? The value I found here was what? This was cost of going from 1 to 2, that was 9, and the cost of coming at 1 itself, which will be represented by distance array. So this represents in how much minimum cost I can reach at 1, that is 0. And from reaching from 1 to 2, I can take 0 plus 9 units of time because that is represented by roots array, right? Let me draw your roots array also. Your roots array looks like this: 1, 2, 9, 1, 3, 10, 1, 4, 2, 1, 5, 6, 2, 4, 14, 2, 5, 2, and 4, 5, 11. So right now, the value that you have here is max, which is the maximum of minus infinity and 9. Obviously 9. So you will update this value with 9. Okay. So update this value with 9. Okay, fine. Now you increment the count of j and parents roots of j comma 1. So j comma 1 was 2. So your parent of 2 will become what? You reach 2 from roots j comma 0 from 1. So parent of 2 will be updated with 1 because you reach 2 from which terminal? One terminal. So I hope you are getting the gist of this entire thing. That distance array is supposed to store the minimum cost I am taking to reach from particular terminal to ith terminal in your distance array. Fine. And let's see in terms of, actually it will have the maximum only, but that negative thing might confuse you. Just see what is happening. Next thing, coming on to the next index. Now your j becomes 1. So for j equal to 1, now you check your roots of j comma what? It was j comma 0, if that is infinity. So roots of j comma 1 comma, this is your roots, this is 1 comma 0. Okay, so 1 is not infinite for sure, so that means that it has been explored and you are checking what all options you can explore from that one terminal. Now you are at this, so you will see in your distance array, you will again see that from 1 to 3 you can reach in 10 units of time, so you will update this with 10, and to 3 you are reaching via 1, so this will be updated with 1. Now you go for the next value in your roots array. You see that you can reach 4 in how many units of time? 1 to 4 takes 2 units of time, so you will update it with 2. you check now. Next, you can reach 5 and 6 units of time, so this will be updated with 6. Okay, so going to the next one. Now checking to reach at 4. So 4 you can reach from 2. So for that you need to know in how many units of time or cost you were reaching at 2. So you were taking 9 units of cost to reach at 2, and from 2 you will reach 4 in 9 plus how much of time? 14. So 9 plus 14 is what? 23, right? So should I update this 4 with 23? See what it is going to ask. It will say maximum of minus infinity and whatever you have. So earlier you had the value distance will be updated with what? Math dot max of minus infinity, and the distance of that terminal that it will store. So you're reaching 2 in how many units of time? 9 units of time. And 9 plus how much time you're taking to reach 4 from 2 in 14. So 9 plus 14 is 23. So distance of 4 should be updated with 23 now. You getting this thing? Okay. Now I have what? I have 2 to 5. So 2 to 5 I can reach in how many units of time? Time to reach at 2 was cost. Whenever I say time, don't get confused. It's simply cost. So cost to reach at 2 is 9. From 2 you can reach 5 in 2 units of time. So that is 9 plus 2, 11. So 5 can be updated with 11. Correct? Okay. Next iteration. Next iteration is checking for, now this is for when I was I at 0, j 0. So this thing will continue. Now your I is at 1. Okay, fine. So for I equal to 1, you check distance, again same thing. You'll start for I equal to 1, you will do the same thing for distance rules again, and you will keep on repeating this thing until you get the these distance will be updated with the maximum cost that it is taking to reach at that, and parent will be updated, and simultaneously parent is updated with that terminal from which you are reaching at that index. Okay, so let me know if you have any doubts so far. Let me check my YouTube live session as well. Okay, so I think you got the gist of this question. Now, the same thing, I suggest you, if you have understood this much, I'm sure that you have understood the, why we are doing the algorithm that we are using. Now, try to make this run. I'm doing that. I'm simply what I have written, I'm showing you via this example. So I suggest you try to do this. I have done one iteration I've shown you. Try to do this thing further for other iterations and see how your distance array is storing the answers. And that is all about this question. So this is a very simple, not very simple, but a direct implementation with a little bit of twist, that here they're asking you to find the maximum cost, and in general our algorithm which I just stated here is used to find the min cost path. Okay, by detecting cycle, if there is any cycle it will return you -1. If you are not able to reach at that terminal, for that also it will return you -1. Okay, so these are the two cases. So if you have understood this problem, I think that is all. Now, if you guys have any doubts from any of the 4 questions that we discussed, or any logic that you want me to take up, if you are naive to that, I can take it up. From contest point of view, we have discussed the questions. Now you can tell me if you have any doubts. So if you don't have any doubts, let's wrap it up. And I'm not a college student, I'm a working professional. So I think that's all for today then, everyone. Try to do the questions that you were not able to attempt in contest. And if you have any doubts, you can come back to the video and check it. Okay then. See you all in the next lecture. Bye bye everyone. Take care.